Hello everyone, welcome back to another video. In this one, I'm in the Godot game engine to show you all something very exciting. As you may have seen by the title, I coded gravity in a 3D environment. Alright, so to get started, I have a main scene, a camera, and a few meshes. For the camera, I just have this basic script, which I will leave down below for a free camera movement. Alright, so in this example, I'll be using a sun and two bodies that orbit the sun. So first, I reference the objects in code. So the different bodies. Body 1 will be the sun, 2 and 3 will be planets. Then I set up the gravitational constant g, which will be 0.5 for this example. Next, I need an array which will store objects. So with these curly brackets, I create one array called solar objects, and inside them, I create another curly bracket array, which has sun, and then I need to put in the node, which is the getChild, the starting position, the starting velocity, the mass, that isn't important, you can just leave it to 1, the radius, and the surface gravity. You can leave these all the same for what I do. And so I've planet 1, planet 2, the node, position, velocity, mass, radius, and surface gravity. Next, in ready, I loop through each of those objects, and then I say the radius of the sphere mesh right here is the radius in there. Same thing with height, I just have to multiply it by 2 because that's the diameter. Next, I calculate the mass of each of the objects, of being the surface gravity times the radius over g. Remember, that's the gravitational constant. Next, I write this function called gravity, which will calculate the attraction. But first, I'll go over acceleration, which will calculate the formula of gravity. So, I've taken 2 positions and 2 masses. The direction equals position 1 minus position 2. Next, I calculate the length, which is square root the power of direction and 2. And I do that for each of the axes. Next, I say var normal equals direction over length. Var mass equals mass 1 times mass 2. This is the famous gravitational equation. Var gravity equals g times mass over length to the power of 2. And then I return normal times gravity. Now up in the gravity function, I have a attractor and a body. I do var step equals 8, and for each step, this is delta time, and I do 1.0 over step. Next, I calculate the acceleration, where acceleration equals the acceleration function, attractor position, body position, attractor mass, body mass, and then I divide that over body mass. Next, I say body.velocity equals body.velocity plus acceleration times dt. And I do that for all axes. Next, I do body.position equals body.position plus body.velocity times dt for all the axes. And finally, in process, I do for h in solar objects, so for each body, for z in solar objects, for each other body, if the first body doesn't equal the second body, then I'll calculate gravity for the first body and the second body. This will basically loop over all of the objects and calculate gravity for each one of them on each other object. And finally, I modify their positions. So body1.translation equals the stored position, solar objects, and then the name and position. And this is the result for that code. I have the sun in the middle. You can see it's being attracted to the planets a little. And then I have these two planets, and they're being attracted to the sun and each other. So that way they can rotate around each other and around the sun. And that's it. Thank you for watching.